Welcome to The Explainer. So today, we're diving into what is honestly one of the most awe-inspiring achievements in human history, the International Space Station. I mean, just think about it for a second. Right now, literally as you're watching this, there is a metallic fortress orbiting high above our heads. It's housing actual human beings in the freezing, cold vacuum of space. It's our greatest modern marvel, hands down. But to truly grasp the sheer magnitude of this achievement, we really have to recognize that space isn't just fascinating, It's an incredibly hostile environment where the stakes are absolute life and death.
To see just how dangerous space travel really is, we have to look back at February 1st, 2003. 7 astronauts, including India's Kalpana Chawla, were heading back to Earth. They just had this successful 15-day mission on the ISS, doing all these microgravity experiments. The whole world was watching, waiting to welcome them home. But then, in just a matter of minutes, a piece of foam insulation struck the shuttle's wing and it caused a catastrophic failure right upon re-entry. Space Shuttle Columbia broke apart, and those 7 brave souls lost their lives. This tragedy completely shook the globe. It literally grounded space exploration for years and drastically slowed down the construction of the ISS from 2003 all the way to 2011. It was this really sobering reminder that we were pushing the absolute limits of human capability, and honestly, survival up there is never guaranteed.
Okay, let's dive right into this incredibly resilient journey. We're going to cover a human home in space, the world's most expensive project, life in zero gravity, miracles of science, and finally, the future of the station.
All right, Section 1, Human Home in Space.
So, to understand the sheer scale of this outpost, I want you to picture a structure roughly the size of a professional football field. Now, imagine that floating in the void, exactly 400 kilometers above the surface of our planet, in what we call low Earth orbit. At this staggering height, over 240 astronauts and scientists from all over the world have lived, worked, and pushed the boundaries of what we know. It is, quite literally, a permanent human settlement up in the stars.
Moving on to Section 2, World's Most Expensive Project.
This journey actually starts way back in the 20th century. In 1971, right at the height of the Cold War space race, Russia launched Salyut-1, the very first space station. The US countered with Skylab, but NASA eventually realized, hey, building a massive permanent station is way too expensive for just one nation. And that realization led to a monumental shift. In 1993, fierce rivals became partners. A global treaty was formed, uniting the US, Russia, the European Space Agency, Japan, and Canada. This unprecedented collaboration paved the way for 1998, which is when the very first modules, Zarya and Unity, finally launched into orbit. And the price tag for all this global unity? A jaw-dropping $150 billion. That is an unprecedented investment in human history. The United States put in around $58 billion, with Russia, Japan, Europe, and Canada pitching in billions more. Get this, even today, it costs about $7.5 million a day just to maintain the astronauts up there. To build this absolute behemoth, it took 36 separate space shuttle flights over an entire decade just to carry the heavy modules up into orbit. So what exactly did all those shuttle flights deliver? Let's take a quick tour. The station is built from these interlocking modules, all connected by highly pressurized docking ports. You've got the Russian-built Zarya module, providing crucial power and propulsion. The US Destiny and European Columbus modules, those act as these massive research labs. Then there's the Tranquility module, housing the life support systems, the GEM, and yes, the bathroom. And for those breathtaking views of Earth, astronauts head straight to the cupola, this incredible glass observation dome. The whole shebang is powered by massive solar panels and serviced by the Canadarm, a giant robotic arm that handles all the exterior repairs. And this brilliantly illustrates the crazy physics involved. To keep this 450,000 kilogram station in orbit, it has to hurtle through space at a staggering 7.5 kilometers per second. Moving that fast means it completes a full orbit around the Earth every 90 minutes. That's right, 90 minutes. So the astronauts on board actually experience 15 sunrises and 15 sunsets every single day. Which brings us to Section 3, Life in Zero Gravity. Existing in a microgravity environment turns basically every mundane human task into a massive logistical nightmare. Think about it. On Earth, you lie down in a gravity-bound bed, you use water-flushing toilets, and you eat fresh food. On the ISS, there's no up or down. Astronauts actually sleep strapped vertically to the walls inside these tiny little chambers, just so they don't float around in their sleep and bump into sensitive equipment. And when they need to use the bathroom, water doesn't work. So they use toilets that rely on suction air pressure to pull the waste away. Water behaves so bizarrely up there that if you soak a washcloth and try to wring it out, the water doesn't drip. Surface tension literally turns it into this weird gel-like tube of water that just stubbornly clings to your hands. It's an entirely alien way to live, right? Down to the freeze-dried food they have to eat just to survive. And the physical toll of this environment, it is immense. Without gravity constantly pushing against their bodies, astronauts' bones and muscles just begin to rapidly weaken. To fight this, they are required to exercise for a grueling 2 hours every single day, using specialized equipment. NASA strictly monitors everything they do, from tracking every drop of their daily water intake to analyzing exactly what type of food they're eating, all just to ensure they maintain their health.
Speaking of food, eating is its own hazard. Resupply ships only arrive every 6 weeks, which means fresh fruit is a really rare luxury that has to be eaten in just a couple of days. Drinks like coffee, well, they come as powders in sealed pouches that astronauts have to inject with hot water. Oh, and here's the fun fact. They have to use magnetic plates so that stray utensils, like a fork or a knife, don't float around and drift into someone's eye or damage the equipment. Yeah, literally. All right, moving on to Section 4, Miracles of Science in Space. Now, what's really interesting about this slide is how it justifies that massive price tag we talked about earlier. You have to look at the unique physics that are only possible in microgravity. Back in 2018, NASA installed the Cold Atom Lab to cool matter down to an unimaginably freezing -273 degrees Celsius. Doing this allowed them to successfully achieve the fifth state of matter, the Bose-Einstein condensate. This is a massive breakthrough. It paves the way for hyper-advanced quantum computers and ultra-sensitive sensors. We're talking about technologies that are completely impossible to create down here on Earth, but could directly revolutionize how we process information and navigate our own planet in the future. The station is also this incredible biological laboratory. To prepare for future missions to Mars and the Moon, we desperately need to know what prolonged exposure to cosmic radiation and zero gravity actually does to human DNA. Enter the famous NASA twin study. Astronaut Scott Kelly spent nearly a year on the ISS, while his identical twin brother, Mark Kelly, stayed right here on Earth. By constantly comparing their biology, scientists discovered some seriously fascinating things. For instance, without gravity compressing his spine, Scott Kelly temporarily grew 2 inches taller. I mean, no way, right? They also observed significant shifts in his DNA sequencing and his gut microbes. Understanding all this data is absolutely crucial, because look, if we are going to send humans to Mars, we need to know exactly how to medically alter or protect their biology before they even leave Earth. And honestly, the milestones just keep coming. In 2012, astronauts started launching tiny, cost-effective research satellites called CubeSats directly from the station. In 2013, the Alpha Magnetic Spectrometer detected hints of dark matter particles. And then, in 2015, astronauts successfully grew a mustard plant. Now, this agricultural breakthrough is critical. A trip to Mars takes about 26 months, meaning we can't just send care packages of food from Earth. Astronauts are going to have to farm in space to survive. Which leads us to Section 5, the future of the space station. So, the crucial point is, the ISS has been an incredible home, but it just can't last forever. The physical wear and tear of space is finally catching up. NASA has extended its operational lifespan to 2028, but after that, the aging structure will be safely deorbited and destroyed. And accelerating this end is the shifting geopolitical landscape. Due to the ongoing Russia-Ukraine war, the Russian president announced that Russia is actually going to be withdrawing from the ISS partnership in the coming years. Without Russia's critical modules, maintaining the station becomes incredibly difficult. Let's move to and see how this builds into the future. Because of these changes, we're transitioning away from a unified global station and fracturing into single-nation efforts. India's ISRO plans to launch its own independent space station by 2030. Meanwhile, the United States is focusing its resources entirely differently. Through the Artemis mission, NASA plans to build the Lunar Gateway. This is a brand new space station that will orbit the Moon, serving as a staging ground for lunar colonies and eventually those missions to Mars. Which leaves us with this final, really profound question. For over 2 decades, the International Space Station proved that former Cold War enemies and global powers could actually live and work together in a tin can flying at 7.5 kilometers per second.
It was the ultimate symbol of humanity looking past its earthly borders. But as we fracture into competing national space stations and lunar races, will the end of the ISS mean the end of international peace in space? It's something we're definitely going to have to watch closely as we step into this next great era of cosmic exploration. Thanks for joining me for this explainer, and keep looking up.